Uh, my topic today is what's new in the solar system? And you might have the reaction, what do you mean, what's new in the solar system? It's been around for 5 billion years. There's nothing new. Well, actually, what I had in mind is this. Uh, it seems amazing to me, but it was 4 years ago when I first taught a class at the Senior Center, and it was about the solar system. And remembering that, I went back and I looked over my old lessons, uh, and I realized that while the solar system is still pretty much the same as it was back then, we know a lot more about it now than we did then. And in even 4 years, we've learned a lot. And so I thought I would talk about some of those topics today. And we're going to start out talking about the sun, since it's the center of the solar system. And a lot of the new things that we're learning about the sun are a result of the NASA mission called the Parker Solar Probe. We talked about it before, but it's been a while. And as it happens, you remember what it's doing is it's doing these long elliptical orbits in which it goes way out in space and then turns around and plunges in towards the sun. And each time it comes in, gets a little bit closer to the sun, whips around the sun, goes way back out into space again. Well, it just went around the sun for the 8th time. And on this journey or past the sun, it came within 6.5 million miles of the surface of the sun, which is closer than any man-made object has ever been before that came back. A few things have been launched and intentionally allowed to fall into the sun, and that's what eventually will happen with the probe when this mission is over. But nothing else has ever come that close and come back or out again. But it's on an orbit that will bring it back out. This time around the sun, it's traveling at an amazing 330,000 miles per hour, which makes it the fastest man-made spacecraft ever. Now, it's going to be a few weeks before we find out what the probe observed on this pass, because it's got to get clear away from the sun before it can do radio transmission back to NASA. Right now, it's got the sun in its way. But we've got a lot of data from its earlier encounters, and astronomers have learned a lot about the sun. When we first talked about the solar system, we mentioned the sun is divided into a whole lot of layers. There's the inner core, which is where the nuclear fusion happens, where hydrogen is fused into helium. And we know that's where the energy is produced that the sun sends to us every day. And we know that the temperatures at the core have to be extremely hot. They have to be about 15 million degrees. Now, we don't know that because anybody's gone in and measured it, because obviously that would be way impossible. But we know it because we understand the physics of nuclear fusion, and we know it requires that high a temperature for fusion to take place. Now, as we come up through the various layers of the sun, when we reach the surface of the sun, that's a layer that's called the photosphere, because that's where the light that reaches us actually breaks free of the sun and comes toward us. And the temperature there is only about 6,000 degrees. So in coming out of the core, the layers of sun have cooled and cooled until we get to 6,000, which is pretty hot, but not nearly as hot as 15 million. But then a very interesting and strange thing happens. just above the photosphere, that is just above what we consider the surface of the sun, there's another layer that's called the corona. And if you observed the total eclipse of the sun back in 2017, then you got a chance to actually see the corona. Because during an eclipse, the corona, when the sun itself is blacked out, you see this glowing film all around the black circle, and that's the corona. And it turns out that the temperature of the corona is over a million degrees. And this has been a puzzle to astronomers for over a century. They first figured out what the temperature of the corona was over 100 years ago by looking at spectroscopic data from the sun. And nobody could understand why it should have, why when right at the surface it's only 6,000 degrees, why does it heat up so much when you get just above the surface? So that's one of the major missions of the Parker Solar Probe. And we have here in this picture, it shows us the orbits of the probe, how it keeps going. This is where it started, and then it keeps looping around and around. And if you notice, if you follow those orbits, every one, it gets a little closer and a little closer to the surface of the sun. And so every time it gets closer, it's able to gather more data. So based on the earlier observations, astronomers have come up with a theory which they think might possibly explain this high temperature of the corona. What you see when you get close to the surface of the sun is that there are magnetic lines that extend out from the photosphere out into space. And there's actually two different types of lines. There's some that are just like open-ended lines that just head off into space. And there are others that come out of the surface of the sun, go up into the corona, and then loop back down. And so they form just these giant loops above the surface of the sun, and right in that area we call the corona. Well, what the Parker Solar Probe has observed is that every now and then, one of the long extended lines that goes out into space will collide with one of the loops. And when that happens, there's a complete reconfiguration of the magnetic field in that area. The magnetic line that went out into space gets turned into a loop. That is, the other end comes down and makes contact with the photosphere, so it becomes a loop. And the loop that was there before, one end breaks free of the photosphere, and so now it becomes a line pointing out into space. And in that process, a lot of energy is released. And so astronomers now believe that that energy may be the source of this extremely high temperature in the corona. Don't have enough evidence quite yet to where they can say, yes, this is it. But this is the first time they've come up with something that seems to provide some kind of explanation. So they're going to be looking at the data from this trip, and this was, as I said, the 8th trip. It's going to make a total of 24, so 16 more trips around the sun. And hopefully with the data they collect from all that, they'll finally be able to explain what's going on with the coronasphere. Now, you might ask, well, why? Why do we care? What do we want to know about what's going on the surface of the sun? One major reason is that we have learned that in addition to the sun having these magnetic lines extended out into space, every now and then we have what we call a solar storm on the surface. And as a result of the solar storm, sometimes we have what's called a coronal mass ejection, which means the sun shoots a bunch of material out into space and it goes flying out in all directions. And depending on where the Earth is, it may or may not come towards us. When it does come towards us, it can be a big problem because that material consists of a lot of it consists of charged electrical particles. And as a result, it tends to disrupt communication, disrupt power systems, and so on. We talked a couple of times in astronomy class about a famous historical example of this that happened in the late 1850s, something that's called the Carrington event, when exactly what I described happens. The sun went through a coronal mass ejection. A huge storm of those charged particles actually did hit the Earth, came down into the Earth's atmosphere. Now, in the 1850s, we didn't have radio. We didn't have a lot of things we have now. What we did have was a telegraph system. All across the United States, there are telegraph wires. And when that incoming material from the sun plunged through the atmosphere, when it hit a telegraph wire, it would cause a huge charge of current to run through those wires. And there were actually cases of telegraph stations that burned down because when this huge blast of energy came down the wire and hit the station, there was no protection there because they never expected. They thought telegraphs were basically powered by batteries, and they thought, well, we're always going to have low voltage, and so they didn't have circuit breakers or anything. And so when this huge voltage came in, it would literally melt the equipment in the telegraph shacks, and then often they would catch fire. So that was actually a significant amount of damage done. But if something like that happened to us today, the damage would be far, far worse, because now we depend so much on radio communication, on the internet, on our power systems, and all that stuff could undergo significant damage. So it's very important that we learn as much as we can about the sun. There's no way we could ever stop one of those things from happening. But at least if we develop the ability to predict when one might happen, then we might be able to take some kind of preventative measures to keep the damage from being really bad. So that's a reason why this research into the surface of the sun and what goes on there is really, really important. Now, in addition to telling us a lot about the surface of the sun, it happens that the Parker Solar Probe has also given us information about the planets. It turns out the camera on the probe has a device called a coronoscope. And what the coronoscope can do is totally block out the light of the sun, so that the camera can pick up light from other objects. And so by using that, the Parker Solar Probe has been able to take pictures of the planets as it rotates in its orbit. And we've got an example here. This is actually two different pictures put together. And what we've got is this bright object up here is Venus. That's the Earth there. And over here is Mercury. And these lines that you see that go right through Venus, that's actually a dust cloud that's in the orbit of Venus. And this is the first time astronomers knew that such a cloud should be there. In fact, there are dust clouds like that in the Earth's orbit and in Mercury's orbit as well, and also in Mars's orbit, because we know those planets were formed just by a bunch of material aggregating together, and the planets mostly are made up of larger chunks of rock, but there was also this very fine dust, and some of it didn't get bound up in the planets and just stayed in the orbits of the planets. And so astronomers have known that there had to be a sort of a dust band that went around in the orbit of all the inner planets. But this is the first time they've ever actually seen a complete picture of the dust band that's in the orbit of Venus. Okay, so we're going to transition to my favorite topic these days, which is Mars, because we're learning more and more about Mars every day. And in Mars being my favorite topic about Mars lately has been the helicopter. And it seems it just won't let us down. It keeps doing astounding stuff. And I don't know if everybody's aware of this or not, but I wanted to make sure that you did know that there's a major announcement at the end of last week from NASA about the helicopter. Leading up to that announcement, remember in class last Wednesday, I was speculating that it would make its fourth flight either maybe last Thursday or Friday. Well, the fact is they attempted a flight on Thursday, but they had the same kind of problem that they had in the first high-speed rotor test. This thing, the proper name for it is a software timer that went off and basically stopped the process of the software getting the propeller going full speed. And when that happened the first time, they went in and they looked at the software and they felt like they had found the problem. But in order and they felt they could make a change to the software and eliminate the problem, but that would mean that everything would have to go through complete testing all over again. The software would have to be transmitted from the Earth back up to Mars, installed in the helicopter, and then they would have to do tests with the software in the helicopter to make sure it would all work. And they decided that was going to take too much time. And so instead, they found a workaround. That's a famous computer term, when you don't solve a problem, but you find a way to avoid it. And so they found a workaround, and it worked, as we know, because the helicopter was able to do its final high-speed rotor test, been able to make 3 successful flights. But then in the fourth flight, they had this same timer problem again. And so they didn't even think about it this time. They just quickly found another workaround to do that would allow them to avoid the timer problem. And so they tried this on Friday, and everything worked fine. They had a great flight on Friday. The helicopter went back up. Now it's this standard flying height now is 16 feet high, goes up to 16 feet and then starts going places. And on Friday's flight, it flew out for 436 feet and then turned around and came back and landed basically the same place that it took off from. And in that flight, it took a lot of images. And we're going to see some of those. But we want to go first. Now, I want to go ahead and let you know. I said that there had been a major announcement from NASA about the helicopter mission, and let's talk about what that is. they have been analyzing all the flight data from the navigation system for all the flights so far. And they've been looking at the images the helicopter's taken, and NASA has decided that they're going to extend the helicopter's mission for another month. It was supposed to be basically for April, which would mean it would be essentially over now. It has one more flight in the current mission, but now they've decided they're going to extend it for another whole month. So the fifth flight, which again, I haven't seen specifically when it's going to happen, but I would anticipate sometime toward the end of this week, it will have a fifth flight in the current series. And the difference in this flight is that the helicopter is going to fly out, but it's not coming back. It's going to fly off in the direction that is planned for the rover to go in. It's going to fly some distance out and it's going to land. And then what's going to happen is the rover is going to start moving and move over to where the helicopter is. And at that point, we get into the helicopter's new mission, which essentially is for it to be a flying scout for the rover. From that point through at least another month, we're going to have that same kind of situation repeated over and over again. The helicopter will fly off in the direction that they intend for the rover to go. It will take images of the terrain as it flies along. It'll get out a certain distance away from the rover and it'll land. Then those images will be transmitted back to the rover, and then from there, they'll follow the path we described before. They get back to the rover sends them to the satellites that orbit Mars. They send them back to the Earth, to NASA's Deep Space Network, and eventually they get back to the mission headquarters at the Jet Propulsion Laboratory in Pasadena, California. And there's two things that are done with the images. One is that the people who actually plan the rover trips look at the images and use them to see any area that might be a problem to the rover as it goes off in its next preferred direction. In other words, don't want to drive over a cliff, don't want to get caught in a big pile of sand, a lot of obstacles that you want to avoid. And they'll be able to do that much more easily because they'll have all these images that are shot from a height of 16 feet instead of depending on images that are shot from orbit. But the other thing that's being done with those images, though, is that the mission scientists who are looking for targets for their science, they're looking for places where they think it might be worthwhile to dig into the rock and see if they can find any possible sign of life, or just to examine the composition of certain rocks to see what information that they can extract. They will have a much better idea of what to look for because they'll have those images to look at. Right now, like for example, with the Curiosity rover, which is still functioning, it drives along and has to stop, take pictures, and then back down on Earth, somebody looks at those pictures and they may say, oh, look, here's an interesting looking rock here, let's check it out. Or they may say, well, we don't see anything interesting here, so let's move along. But now they'll have those pictures before they move into a location. So if there are interesting things that the scientists want to look at, then they'll be able to tell the rover drivers, hey, go by here and stop. And we want to run some tests on this rock over here. So what I'm really describing if you remember way back when we talked about this mission, we said that the helicopter part of the mission was just a test. It was a test to see if in the future that a rover could function with a helicopter scout. Well, we're not waiting on the future. It's now. It's happening right now. That's exactly what's going to go on. And the reason that they're able to do this is the results they've gotten from examining the navigation data, because it shows that the helicopter is just doing a totally incredible job, that it's able to go exactly pretty much where it intends to go, and land within less than a foot of the place that it intended to, that it can head in a direction and hold that direction, even if the wind's blowing pretty hard. So it's basically showing us that this navigation software really performs incredibly well. And so that's the reason why they can go from a demonstration into an actual mission. Now we're going to look here at a video of the fourth flight, and it's actually got, at the end, it's got some pieces of the videos from the earlier flights as well. But what I want you to notice is here we are ready to take off. Now notice those two flat rocks right in front of the helicopter. And the reason I want you to notice those is to see what happens when it comes back. Now this is the more distant camera. There it goes, going up to 16 feet high. And here it goes, headed off. It's going 400 feet downwind. Now what happened there is we had a transition from one camera to the other when the background color changed a little bit. And that's something they have not been able to do before. So that was quite an accomplishment on that. But once again, now it's gotten out of the range of the cameras, but it's gone further down and turned around. And here it comes back again now. And here again, it transitions into the first camera. And now it's going to land. If you look closely, you will see those same two rocks just to the left of the place it landed. So it came back to almost exactly the same spot that it left. And you might say, well, sure, somebody's flying it. No, no one is flying it. The helicopter does that on its own, just by reviewing the pictures that it's taken. Now here is an image of the helicopter camera itself showing its shadow flying along. And now we're going back. This is the image of the third flight. And once again, it goes off, comes back, and lands. And you can see that's a much shorter flight than the fourth one was. And then next, we've got side-by-side images of the second and first flight. And I know we've all seen it before. The main thing I want to point out here, there's the first flight. You see, it only went 5 feet high there, whereas in the second and subsequent flights, it went up to 16 feet. Okay, so we're going to stop with that. Come on, change. Trying to get to my next slide. Da, 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 da. All right, I'm going to have to break out of this for a second. Sorry, this is my first time running this on the laptop, and it does not behave exactly the same way, which is something I feared. Okay, so finally got us out of that. Let's get back into we we are going to talk about a couple of new things in the solar system. One of which we've talked about before, and that's the famous Oumuamua, which we've basically seen there are two explanations currently offered about it. Uh, One is that it's an interstellar asteroid, that it's just a piece of rock that came from another solar system. The other is that it's an alien space probe. And when we talked about what the basis of those two arguments are, and they're both just based on analyzing what astronomers were able to observe of the orbit of this object. And unfortunately, there's no real way to, I mean, the more practical thing to say is, okay, it's an interstellar asteroid, because it's, what are the chances it's actually an alien spacecraft? But it could be. And the fact is that it's gotten so far away now that with no telescope that we have can really resolve it anymore. And so we're just not going to find out anything else about it. Really, the only thing that the only way we'll resolve this is that whichever is true, and again, the much more likely it's just an interstellar asteroid, we will almost certainly see more of them. And hopefully the next time we see one, we'll be able to follow it more closely and ascertain for sure that's what it is. But we just have to wait and see. But in the meantime, a second interstellar object has been detected. And we haven't really talked much about this one, mainly because there's no real controversy about it. We know what it is. It's an interstellar comet, and it's called 2I Borisov. Borisov is the name of the guy who found it. He was an amateur astronomer in the Crimea, and he found it in August of 2019. And after he reported it, professional astronomers started observing it and plotting its orbit. And after a couple of weeks, they said, this thing came from outside the solar system. So it's the second object that came from outside the solar system. But in the case of Borisov, there hasn't been any controversy, because it acts like comets that come from our solar system act like. As it went around the sun, it developed this long glowing tail, just like regular solar system comets do. But when the astronomers were able to do spectroscopic analysis, they noticed a couple things. One is that some of the material that showed up in the spectroscopic data, while it's the same kind of thing that we see in solar system comets, the proportions of various chemicals were different. So that's a sort of an extra supporting factor to say that it came from outside the solar system. The other thing is that some of those materials did actually resemble one terrestrial comet, and that's the comet that anybody who's a real sky watcher will remember, the comet called Hale-Bopp, which I think it was 1997 it came by, and it was actually visible to the unassisted eye. Anybody could walk out at night and look up and see it. And it's been a long time since there's been a comet like that. Well, what astronomers decided about Hale-Bopp, the other thing about it was when it appeared, it was a total surprise. It wasn't like, it it's Halley's Comet, and we expect it to come back in such and such a time. There was no record of any previous observation of this comet. And what astronomers believe was it came from far out in the solar system, and it was making its first trip around the sun. Something had happened out there that disturbed it and pushed it into an orbit into the inner solar system and around the sun. And they decided that because when they did spectroscopic analysis on it, they saw certain differences in the chemicals that they observed that they don't see in normal comets that have gone around the sun a number of times. Well, it turns out when they look at Borisov, they see the same sorts of things. So what their opinion is that this comet came from another solar system, but in its own solar system, it had never actually gone around its star. That something happened in its solar system that caused it to escape, and it flew across interstellar space, came into our solar system, and when it went around our sun, it was its first trip. And we're going to look at a short video about this. So they say maybe the most pristine ever found, meaning that they think it is never ever passed a star before. Now this is all animation. This is not any actual, except those are actual pictures of the telescopes. But now here is a genuine photograph taken of the comet. It's the glowing object with the tail you see there. Everything else looks smeared out because they focused on the comet itself. So they got the camera synchronized with the comet's speed, and everything else looked like it's going at a different speed, so it smears. So it's interesting, and it sort of tells us something about the system that it came from, in that it behaved not all that differently from comets in our solar system. Now here's a picture of the orbit of the comet, and you can see right down here, these are the orbits of the planets, and you see they all lie within a single plane. And this comet comes in, makes one pass close to the sun, and then heads back out of the solar system again, off into who knows where, into interstellar space. So it is our second genuinely new object in the solar system. So finally, we want to talk about one more, not really well, actually, there is a new object involved here, not totally new, but it would never have been known if it weren't for this mission. When we talked about Pluto in our astronomy class, we mentioned the NASA's New Horizons mission that went to Pluto, and we saw some terrific pictures that it took. But we know it didn't stop at Pluto, it kept going. And it went on out into what's called the Kuiper Belt, the region that's far beyond Pluto. It visited a small body there, which we're going to see a picture of in a minute, that's now called Arrokoth. And then it went on, and it's still going on. And it came to my attention because it just reached a major milestone. It just got to a distance from the sun of 50 astronomical units. Now, we remember, and an astronomical unit is a distance from the Earth to the sun, so it's 50 times further away. which is a long, long way out there. And right now, it is the fifth man-made object to have traveled such a distance. The other four are NASA missions, Pioneer 10 and Pioneer 11, and Voyager 1 and Voyager 2. They've all traveled more than that, and they're all outside the solar system. And that's where New Horizons is headed. But the people who are in charge of the mission are hoping that they can find one more Kuiper Belt object for it to visit and photograph. And if they do that, then we would indeed see another object, not really new, but at least we would see pictures of an object that we had not seen before. And so just a couple things at the end here. This little chart here is showing us the positions of, there's New Horizons right there. This is that little chunk of ice and rock called Arrokoth that it went by, and it's continuing on in this direction. And we see here's where Pioneer 11 is. Pioneer 10 is over here, and here goes Voyager 1 and Voyager 2. So that gives you a relative idea of where they are. All of them really way out there. This is a picture of Arrokoth, the Kuiper Belt object that was visited by New Horizons. And it basically just, they think it's just a couple of chunks of material that bumped into each other and joined at this little white line we see right along here. And we're going to end with this picture here, which is, it's hard, you look at it and say, well, what's that all about? It's very interesting because if we go back to here, here's where New Horizons is, and there's where Voyager 1 is. What that picture is, New Horizons pointed its cameras towards the location of Voyager 1. Now, Voyager 1, of course, is so far away and so tiny that it doesn't show up, but that little yellow circle is where Voyager 1 is. So it's way out in interstellar space. Sometimes this is kind of New Horizons' way of saying, how you doing out there, buddy? Okay, so does anyone have questions about today's presentation?
I have a question, Bill. It's about
Sure.
the Parker Solar Probe, and
Mhm.
that it is the fastest thing, the fastest man-made spacecraft. And I'm wondering why it is so fast. What makes it so fast? Is it the orbit? Is it what it's made of?
It's well, it's two things. It was they used a bunch of solid fuel boosters when they launched it, so it got more speed than your typical space probe would get. But you hit the nail on the head with the orbit. The orbit is designed in such a way that it went, actually when it was launched, it didn't even go toward the sun. It went away from the sun originally, got a certain distance out, turned around, and came flying back past the Earth. And when it flew past the Earth, then the Earth gives it what's called a gravity assist, which is that, it doesn't go into orbit around the Earth, but the Earth's gravity kind of gives it a little extra shove. And then it did the same thing with Venus. And actually, it's doing that with Venus. If you remember what all those orbits look like, every time when it's away from the sun, it goes out to the orbit of Venus, circles around Venus, picks up another gravity assist, and that gets it going faster. But then the ultimate thing are those passes around the sun, because it comes so close to the sun that the sun's gravity is trying to pull it in. And it doesn't succeed in doing that. But what it does do is speed it up even more. So every orbit around the sun it goes a little bit faster. I think by the end, it'll be going close to 400,000 miles an hour.
Wow. That's so great. Thank you.
Sure. Other questions? Okay, well, I'd like to thank everybody for joining us today. Remind you, no class tomorrow, but next Wednesday, we're back on our regular schedule. So I hope to see everyone then.
Thank
So
you,
thanks
Bill.
for coming today.
Thanks for being there on your vacation.
Okay,
Bye.
bye.